Hello everybody. So my name is Andrew Carlson and I will be running you through how we are currently using Tremor with OpenTelemetry and the OpenTelemetry components to basically collect logs, ship them, process them, and then eventually ending up in a downstream system. So I am basically a father of three, two children, one boy, one girl, one dog. I got a wife, so I'm a husband. I'm an ex-biker, now basically spending more time on running because it takes less time to get something done. I love to fiddle with tech, so whether it be Legos, like technical Lego or something like this, or whether it be cloud native tech. I've been mostly doing that since I was kind of like 5 years old. Today spending a lot of time with cloud native technologies like used to do OpenStack, now doing a lot of Kubernetes and cloud native ecosystem projects, where Tremor is one of them. We are a department, basically, working within a large IT company called Tietoevry within the Nordics or within Europe. We mainly focus on the Nordics at the moment, but we do have some international customers as well, where we deliver like society critical solutions, where we deploy across the Nordics at the moment in a lot of legacy data centers and some more greenfield in cloud. So our journey with logging began roughly with 2 to 3 years ago. We thought that, okay, let's do it simple. We won't use any index-based logging system. So we focused on a system that was supposed to be easy to run with few components, few moving parts. We wanted to use something that used object storage just because then we could have like infinite storage in Azure. We want to use existing tooling for developers, so stuff like the CLIs or the APIs or the UI for the developers. And we wanted to reuse known concepts for developers, so stuff like how do you get data about what you're going to be able to search about. So stuff like labels, tags, metadata about that. How is that exposed through, or those concepts, building blocks exposed through the tooling that the developer is going to be using. So along came Loki with a good phrase, "Your savior is here," if you've seen the Marvel movies. We selected, or had already started to use and selected Grafana for metrics and visualization of those. So we then used Grafana UI for basically putting that on top of the Loki one. It had a CLI that you could use, or the log CLI that we didn't really start to use. But then you could basically search for the logs or query the logs using the labels. So you can add this promql query that looked pretty familiar to you if you were known to stuff like Kubernetes labels and the promql. So we just thought like, okay, this has got to be nice, right? But well, you know, developers and humans, or humans just be humans. So non-index logging stack, when people are used to stuff like Elasticsearch and other environments in our department, turned out to be a no-go. Like they thought that it was more primitive than what they were used to. Assuming that people want to use logql or Loki, even though it's a nice UI and all this, they were like, nah, I like my index logs. And then trying to think that making value out of JSON-based logs, where people logs in additional metadata about their log events inside of the JSON payload using MDC in Java, or like Sarilog in .NET or anything similar. making that useful in a powerful way within Loki is to kind of like, you know. And then we basically ended up with a hat trick or more with some Simpson moments during the last 3 years that were basically the limitations then of us using Loki. So this is how you feel when you go to a developer or a person like operations person that's used to something like the Elasticsearch. They're like, oh, why can't I basically put anything in here and just have it indexed? Like in my view for my app and whatever. And they kind of go like this, why human, why? You know, it's like the cat that's just been showered when they look back at you with despair. So we went into a new iteration where basically we said, okay, we want to be able to scrape any kind of log, whether it be application, system, networking, from any kind of place. We want to be able to receive any kind of log in different points in our infrastructure or environment. So whether that being then able to receive OpenTelemetry based by gRPC HTTP, TCP logs, TCP based events, or like events coming over TCP, UDP. We don't support GELF because we had that, like Raylog extended format. Syslog, and basically any kind of, you know, the legacy kind of thing in addition to the new thing. Want to be able to take those, ship them all off to like a standardized logging pipeline, and then make them available to different downstream system. So we made a decision to then, okay, we gotta support index logs. We want to have a nice UI and API with RBAC and SSO, like single sign-on. We want to use well-established tools or components that hopefully we don't have to spend a lot of time to figure out. Stuff like the RBAC and stuff like this. They need to be able to support filtering, routing, QoS. And as an example, we don't want to have health checks showing up in the downstream system because it's just inconvenient, and there needs to be a well-established or be backed by a good community, basically. So being, for example, a CNCF project, or having a nice vendor behind it, or several users with a vendor is a must. So I just had to dub it the Toro stack. So I didn't put any logo here on with like a bull or anything, or like the Spanish variant, but it's basically Tremor, OpenTelemetry, Red Panda for Kafka as a replacement for Kafka that's typically used in these kinds of systems, and then OpenSearch with OpenSearch dashboards, or Grafana for doing stuff like visualizations and queries. So we kind of like Tremor, or I like it, and we see that it can do a lot of things, mainly because it gives you a TCL Lua inspired or lookalike DSL combined with SQL that is very powerful in the way that you can express stuff like building pipelines, building the flows that you want to build, and doing stuff like transforming data, filtering, providing quality of service, like being able to express stuff like circuit breaking, having built-in write-ahead logging if you need to do batching, and all of these other stream processing and transformation logic. Once you've been working with it for like a day or like a week, using more and more Tremor for various tasks of these kinds of things is very nice, I think. We wanted to have a nice community around it. So Tremor, sadly, at the moment is maybe not like the most well-known project, I think, from CNCF, but it has a very nice ops team at Wayfair focusing on observability, and you have a lot of users in the Discord, and the team is like super helpful to give you any kind of help or advice, or help you if you struggle with stuff. We use OpenTelemetry mainly for the agent and the wire protocol. So meaning thinking about how will it look once it leaves the wire, or the like the API format of the payloads and so on, and also being able to reuse stuff like SDKs for applications, being able to have one standard to think about when you're sending the data between different components in the stack. And of course, OpenTelemetry is like a huge community. I think it's larger or equivalently to Kubernetes at the moment. So next up, we'll take a look at our architecture around, or what we're working from when we're now setting up these new pipelines. This is all a bit like work in progress at the moment, but we have some concepts and some already in production shipping pipelines. So first off, let's start off with collection. So the first part of our logging pipeline is basically OpenTelemetry collectors typically, that will then scrape logs off of a file, do some stuff with it, and then ship it off. Or if it's inside of a Kubernetes cluster, you might have applications on that node sending logs to it directly if they want to. So we have a OpenTelemetry collector that's then sitting as a daemon set typically in Kubernetes, or installed onto a server like a VM or like a bare metal box. In Kubernetes land, it kind of looks like this. So this is based upon the example that you would find in the OpenTelemetry collector. So basically, we're just scraping the logs, they're coming in here. This is our implementation of the file log receiver. So we get the logs, they're scraped, determine if it's like Docker, Cryo, Containerd. We then extract some metadata from the attributes inside of it. We move some logs around, or some parts of the event. We then detect, okay, is it JSON or not? If it's not JSON, we're going to be skipping a lot of the pipeline and heading off to this last part. And if it's JSON, we determine, is it like certain format. We have Perl, is it MDC based? And if not, we just skip on and then move along to this right side part. So we use this then to be able to, in the next stage of the OTEL collectors' pipeline, to determine, okay, are we going to drop data? Like if it's data about, say, Kubernetes was here and scraped the app, or Prometheus was here and scraped the app for metrics, any kind of health check data, but we can determine that, okay, this event is like a health check one. We're just going to be dropping that event instead of shipping it off further down the line. This happens within the OpenTelemetry's filter processor. So we use a processor inside of that. Once it exits the previous pipeline, it goes into the pipeline, if you will. And then we have this filtering processor here that's going to be detecting like if this is health check attribute present, and then it's going to be skipping, sending it on further down the line, then to stuff like Tremor or similar. We also can do some other things inside of the processor, so we can enrich any metric or log or trace event with information about what Kubernetes node it's on, using the Kubernetes API, for example, or if you're in Azure or cloud, you can enrich it with using the metadata, instance metadata endpoints. So you can add stuff like, okay, which virtual machine scale set is this? What virtual machine is it? And a lot of metadata about the underlying infra, basically. So moving on, we come into a concept of a forwarder gateway, or the stage 2 gateway that we call it. And this is thing that can be deployed within a workload cluster in a given environment, or on a VM, if you will. In our current environment, we're deploying this to a Kubernetes cluster. This is then receiving, it has a load balancer IP, basically then, that other things are connected to out of the cluster. So this red line that you see here basically denotes stuff that is outside, but we also have in cluster in this example, sitting inside of the same cluster that the Tremor is in, OpenTelemetry agents that are scraping logs and then shipping to this one. And then we have some legacy stuff running on a different cluster and different infrastructure. And this is then sending logs down into Logstash. And then the power of Tremor comes into play when you can say, okay, I want to deploy a flow with a pipeline that's going to take the Gelf logs, like the gray log extended formats on either UDP or TCP, convert it into OpenTelemetry logs, and then in the same Tremor, we deploy a separate pipeline, which we call the OpenTelemetry forwarder. And at the moment, this yellow part is not deployed with it, but it's just a stupid server and a client. So this Gelf thing then sets up a forwarder to itself on localhost on a gRPC server, and then this takes care of forwarding down into the out of cluster or out of environment based Tremor. I'll show you the code for that. So 2 seconds. So here you can see we basically have a Troy file, or like a deployment config, that we deploy a Gelf forwarder and a OpenTelemetry forwarder. And what this is going to do is going to start up a Gelf compliant listener on UDP and TCP that basically will forward to the same Tremor, if you will, or to a different Tremor depending on the address here. That's then listening and just forwarding off again to a downstream Tremor, or like a downstream OpenTelemetry thing. And it's pretty simple. It's this is just wiring up basically a OpenTelemetry server like here with gRPC and a client to send it further down the line. And it has a write-ahead log at the moment. The Gelf forwarder is looking like this. It's setting up different kinds of Gelf receivers or connectors with UDP, TCP, UDP compressed, forwarding it into a transformation pipeline that will then convert it into OpenTelemetry, and then connecting this back into, again, the previous one that you saw. So this, all in all, is pretty simple. Moving along then to the next stage, we'll be receiving the events into a downstream stage 3 Tremor. This is going to be receiving the OpenTelemetry logs and doing what you saw on the previous slide, where basically then we'll do normalization and basically unpacking the inner logs often. So stuff like if you have a component that's logging syslog, if it's logging JSON-based inner logs, stuff like traffic, for example, access logs and app logs from traffic, or other components like Cilium, they will often log JSON events inside of the body field of the OpenTelemetry log. And then we do that in this OTEL normalize step here before it goes on to Kafka. That basically looks like this, wiring up a gRPC OpenTelemetry server and a Kafka producer with a suffix. And then we have some metrics topic as well. But then we basically receive this here. We expand the batch payloads from the OpenTelemetry ones. We then parse any kind of JSON that comes in, which is sitting in the body field of the OpenTelemetry payload. We then run this normalization on it. We filter out any health checks that are detected, and then we throw it on to Kafka for further processing like this. And this pipeline, let me show you this. This is the one that is going to be expanding it. So it just uses a lot of group bys into different stages. Then this is the health check filter that runs after the normalization. And you can see here it's pretty nice inside of Tremor to be saying, okay, if the payload has a request method in it, then I want to remap the event into from traffic to OpenTelemetry. If we go here, you can see then it's running a function that's basically extracting all of the inner traffic stuff into what you would call the OpenTelemetry standard, or in the OpenTelemetry specification. So stuff like TLS cipher field information, HTTP forward information, and like HTTP host and all this is extracted from the traffic one and set as attributes. And then we replace or like return a new event that has all of this information set as attributes in one way across either traffic logs, Java-based MDC logs, or whatever kind of access log it is. It will all basically, once exiting this pipeline, is the idea be the same for further processing down the line. Going to the next step, when we exit the first OpenTelemetry one, we're going to go into converting the logs to ECS format. So that's Elastic Common Schema, but it might also be other components listening to the OpenTelemetry logs, because ECS is more specific if you want to have the data inside of OpenSearch that we use. So we have the same concept here then, popping the data off of the OTLP logs that you saw in the previous slide, taking them in, and then running this convert OTEL to ECS, dropping it off again into an ECS logs with a suffix. So that would typically be like a tenant name within our environment. And we can take a look at that as well. We have a convert OTEL to OCS, or ECS Tremor. This is going to do the same thing pretty much. It's going to be unpacking the data. It has different mappers. So for example, it has a generic mapper for anything that doesn't have any specific attributes, and then we have some specific converters that are run for Cilium, for example. So we remap flow-based logs to ECS format. And the same thing if it's process data from Cilium Tetragon or the Hubble Enterprise. We will be running that as well here, and then you can apply specific mappers, for example, for access logs or like other kinds of specifics that you want to split the logic into a separate function, and then use the dataset attribute that comes either from the previous pipeline or even from the OpenTelemetry collectors to then determine what you need here to map. So we have a mapper then, for example, for Cilium, that's then mapping basically here. If it's a flow, we remap all the data from the inner flow logs that are not converted to any OpenTelemetry specifics, but then into ECS formats here. And then we can search any kind of OpenTelemetry based flow logs in ECS format in OpenSearch, which is pretty nice. So reach out if you need that integration for anything. And then lastly, we have a separate one that's the sole mission is to basically pop stuff off of the ECS logs topic and then drop it off into Elasticsearch. And based upon the example in Tremor, we have a index success one and an index error basically topic in Kafka. And the error one is specifically interesting if you have errors, like if you manage to, for example, inside of the message field in ECS have inner JSON and you haven't turned off stuff, or it fails for any other kind of like schema error, it will then pop it off into the error topic and you can go and investigate and say replay those events. So lastly, I think I'll show you a demo that I have running. So let's start off a couple of things. We'll start off with a metrics ingester here. So this one is going to be popping off the generated metrics on the processor metrics topic and dump them into Victoria metrics so that we can go measure how many events basically are running through the system. We'll start off the stage 2 thing that we have. And you'll see that this is going to continue failing until the next one comes up. We'll start up the stage 3 one, which is the one running the gRPC OpenTelemetry server. And I just see now that I need one more topic or one more window to run the ECS conversion one. So let's start that one up as well. I need to load my variables because I don't have the Tremor path set. And I know the windows are pretty small at the moment, but these two ones down to the right, they don't really log anything of interest. So we can go here now, and I have a example program basically running inside, or that I can start with this go. It's a very simple program. If I show it to you, you see, just need to check the time. Let's go here, and you can see that it basically has an address to send to. It's going to log that, okay, it's going to start up this new writer if it has it set, and it's going to be looping 10 to 200 items continuously, and then sleeping for around or like for 500 milliseconds, and then it sleeps with a random duration. I just try to make some example code just to try to generate a random amount of logs, and then it sends it to the first Tremor that we just saw in the stage 2 example, or the diagram that we typically deploy to different environments to do forwarding. So I'll start this up. I need to have my go path set, and then we'll start 2 of them up. Here to set the go path, need to change the correct directory, then we'll fire them off. And now you can see this middle one here that actually logs how many things it's actually forwarding and stuff like this, because I have the pipeline set to log metrics basically to the console versus shoving it off over to Victoria metrics. But if we now go and check here, so if we go here and see, you can see I have all my logs preserved in basically in one format, because we have our own, we extract the data from OpenTelemetry format and then just put it on like this, where every event inside of the nested structure that comes in would be one-on-one event basically. So it contains the resource information, the log, and then the attributes that's been converted. And then some resource information like the host name, and currently I don't have any other stuff here forwarded. But this could be like the Kubernetes cluster or like the app or like whatever. And this is actually using the previous payload version of OpenTelemetry, so it's still called instrumentation library logs and stuff like this. It's going to be changed to scope logs, so we'll have to look into changing that. And we generate like a unique span ID if there isn't any in this OTEL, the Gulf to OTEL example. And then we can go in and see we have a ECS logs topic. This will then contain the ECS logs basically converted from the last step. So if you go here, you see that this then has all the logs converted from the previous format over to this one. So all in all, working with this in Tremor is pretty nice. There is no nested YAML kind of thing to do transformations in both a good and very neat way. So if you want to do like JSON transformations and all of these things, I think Tremor is super cool and simple to use. And I'm quite looking forward to see the clustering support, where you can basically deploy a different tiers of Tremors in clusters, and then basically deploy whole apps of Tremor flows, basically, or set of Tremor mini apps, basically, to a Tremor cluster, and have them run as a stream processing engine in a whole cluster, basically. I think that can be a super cool feature to test out. Other than that, thank you for your time, and I'll show you lastly the log or the dashboard if it works. So let's check with the last 15 minutes, and you can now see that the processing, where we have a separate Tremor popping items off the processor metrics topic, is then showing up here. And if we, just as a last test, go to cd, change the directory, go to Gulf Go, start a last process like this. So now we have even more running. Then we should be able to see that this statistic should be roughly increasing with 60, count of 60 to the published OTEL messages, and the consumers should be following basically. So come on, please work. I haven't sacrificed like a cat or anything to the demigods lately, so it might be that this won't work. Oh, there you go. There's an increase. Obviously, saying that you want to sacrifice something to the demigods is worth something. Okay, so let's set it to 5 seconds. I'm just going to click spam it to see if this will be refreshing. And of course this depends, a lot of this statistics here, like the consumer ones and this, will be depending on how often Tremor publishes those and what you've tuned your pipelines to, because there's a config settings that says something about like how often, if it's a pipeline metric, how often should it be publishing. And now you can see it's steadily increasing, and then if I shut down this last one, it will be decreasing, of course. So nice talking to you all. Thank you for your time and have a nice day.